It's 2 million years ago. You're an early human, asleep on the African savanna. But you're not in a tree anymore. Your ancestors used to sleep in the canopy, safe from predators, curled up in nests of branches and leaves. But you, Homo erectus, you've started sleeping on the ground. And tonight, something strange happens. You stand up. Your eyes are open, but they're glassy, unfocused. You take a few steps forward, navigating around rocks and sleeping companions with eerie precision. You're not awake. You're not dreaming. You're somewhere in between. You are sleepwalking. And here's the thing that might surprise you. No other animal on Earth does this. Not chimps, not gorillas, not wolves, not elephants, not even dolphins. Animals that sleep with half their brain at a time. True sleepwalking, standing up, walking around, navigating obstacles, all while completely unconscious, has only ever been documented in one species: us. So why did evolution leave this bizarre glitch inside the human brain? And did our ancient ancestors really sleepwalk? Or is this a modern problem? To answer that, we have to look at how human sleep evolved. And the story starts with a decision that changed everything: coming down from the trees. For millions of years, our primate ancestors slept in the canopy. It was safe. Predators couldn't reach you. You could sleep deeply without much fear. But when early humans began transitioning to life on the ground, likely around 2 to 3 million years ago, everything about sleep had to change. The ground was dangerous. Big cats, hyenas, snakes. Sleeping on the ground meant you were vulnerable. So evolution did something remarkable. It compressed human sleep. We started sleeping shorter, deeper, and more efficiently than our primate relatives. Chimpanzees sleep around 11 to 12 hours a day, in long, fragmented stretches. Humans? About 7 to 8, in one consolidated block. Evolution essentially said, you're on the ground now. You can't afford to sleep lightly for 12 hours. Sleep hard, sleep fast, and get it done. But this optimization came with a side effect. Sleep isn't one uniform state. It cycles between REM sleep, where dreaming happens and your body is paralyzed, and NREM sleep, the deep, restorative phase. Sleepwalking happens during NREM sleep, specifically during the deepest stage, called slow-wave sleep. Here's what's happening in the brain of a sleepwalker. Part of the brain is in deep sleep, while another part, the motor cortex, the part that controls movement, partially wakes up. It's not a dream. It's not full wakefulness. It's a hybrid state, a neurological no man's land, where your body is active, but your conscious mind is offline. David Sampson, an evolutionary anthropologist at the University of Toronto and author of The Sleepless Ape, has spent years studying how human sleep evolved. He argues that the very things that made human sleep efficient, shorter duration, deeper slow-wave sleep, rapid transitions between states, may have also made sleepwalking possible. In other words, the same evolutionary pressure that made us sleep less and sleep deeper also created the conditions for the brain to occasionally get stuck between states. Think of it like a car transmission. Most of the time you shift cleanly from park to drive, but if the transmission is designed for speed and efficiency, not durability, occasionally the gear sticks. You're in both gears at once. The engine is running, the wheels are turning, but nobody's steering. That's sleepwalking. And it's surprisingly common. About 5% of children and 1.5% of adults are active sleepwalkers. Most grow out of it. Some don't. And throughout history, sleepwalking has fascinated and terrified us. Hippocrates wrote about it. Aristotle tried to explain it. Shakespeare turned it into one of the most haunting scenes in literature. Lady Macbeth, wandering through the castle, rubbing her hands, muttering about blood that isn't there. But here's the question. Did ancient humans sleepwalk more than we do? Or less? We don't have sleepwalking records from the Pleistocene, but we can make some educated guesses based on how sleep environments affect sleepwalking today. Modern studies show that sleepwalking is triggered by anything that fragments deep sleep: stress, sleep deprivation, fever, alcohol, certain medications, and, importantly, sleeping in unfamiliar or uncomfortable environments. When your brain is struggling to maintain deep sleep, it's more likely to slip into that hybrid state. Now imagine you're an early human. You're sleeping on bare ground. The temperature drops. A hyena laughs in the distance. Your infant is crying. You're stressed, cold, and exhausted. Your sleep is constantly being interrupted by environmental threats. Under those conditions, sleepwalking may have been more common, not less. But here's where it gets interesting. Some researchers believe sleepwalking might not be purely a glitch. It might have had a function. Imagine a predator approaches the camp at night. A sleeping human suddenly stands up and walks, not toward the predator, but away from it, navigating the terrain with surprising accuracy. Is that a malfunction, or is that an ancient survival mechanism, a partial arousal response that gets the body moving before the conscious mind even registers the threat? We don't know for sure, but the fact that sleepwalkers can navigate stairs, open doors, and sometimes even perform complex tasks, all without any conscious awareness, suggests that the brain's ability to enter this hybrid state isn't just an accident. It might be a feature that evolution kept around because occasionally it was useful. There's another angle too. Humans are the only animal that sleeps on the ground and has a massively expanded prefrontal cortex. That's the part of the brain responsible for planning, decision-making, and, critically, inhibiting behavior. When you sleep, the prefrontal cortex goes largely offline. But in sleepwalkers, it stays offline while the motor areas come online. The result? A body that can move and navigate, but a mind that can't judge, plan, or remember. No other animal has this specific combination: ground sleeping, compressed deep sleep, and a prefrontal cortex large enough to create a dramatic gap between motor ability and conscious control. Sleepwalking, then, might be the unintended consequence of 3 evolutionary innovations that made us human, all colliding in the dark. So the next time you hear about someone walking in their sleep, don't just think of it as a quirk or a disorder. Think of it as a ghost of our evolutionary past, a reminder that the way we sleep was shaped by millions of years of survival on the ground, in the dark, with predators circling. Your brain is doing something no other brain on Earth can do. It's just doing it with its eyes closed. If you found this interesting, subscribe for more videos on the hidden science behind human behavior. And if you've ever sleepwalked or watched someone do it, tell me your story in the comments. I read every single one. I'll see you in the next video.